Hi and welcome to Maths at Derby and tutorials this week, and I have Jake again with me.
Hello, how you doing?
Yeah, good, thanks. And yourself?
Yeah, not bad.
Now Jake wants to talk about matrix multiplication, but before we do, I've got an important question to ask. Have you washed your hands?
Of course I have. Have you?
I've washed my hands.
Do you know the song for washing your hands? The mathematical song, I should add.
I do know the mathematical song. Should we sing it?
Go on then.
Okay, so it's
3, 2, 1, go.
10 green bottles standing on the wall, N green bottles standing on the wall, and if one green bottle should accidentally fall, there'll be N minus 1 green bottles standing on the wall. That's about 20 seconds.
Yeah, close enough.
Just
And enough for what the people will want to hear at least.
Yeah, that's right. That's probably enough of us singing. Anyway, hope that's helpful. Anyway, down to business.
Yes.
Matrix multiplication. So what we wanted to have a look at today was how we multiply matrices. Now, when I kind of first look at matrices, I was just kind of a bit confused. It's like, why do we have all these like boxes of numbers that we multiply with other numbers in these like really unusual and difficult ways?
Yeah, it's really bizarre, isn't it? But it's got really good applications. So even at a basic sense of solving simultaneous equations with more than, say, 2 unknowns that we can do quite quickly by hand, or you could stick them to higher powers, which is obviously much more difficult to solve by hand and takes a long time, whereas using matrices it can be quite quick. But we can do that in maybe another video, perhaps.
Yeah, we can explore it a bit more. Yeah, exactly. Well, because we've learnt it this year in our first year. We've learnt it in analysis and algebra, and we've learnt it in mathematical software, and we discovered there's even a piece of software called MATLAB, which is Matrix Laboratory, isn't it?
Yes, Matrix Laboratory.
That's how important these things are. So we won't learn until next year what this is kind of all really about, the real applications for it all in linear algebra. So really looking forward to that. But we need to know how to do the matrix multiplication first. So our lecturer in analysis and algebra showed us this really cute trick, didn't he?
Yeah, it's a really handy method, because before I was doing it completely differently, getting really confused as what goes where, and this just makes it so much easier.
Because people talk about like turning it on its side and
flip it around and then sort of like look at it upside down and
you get a headache by the end of it. But Mirko's trick was to just to shift it up, wasn't it?
Yeah, to shift it up. I guess it's worth mentioning before we even do an example of kind of how the dimensions needed for matrix multiplication.
Yeah, well, like if I go through that then briefly. So what his trick was to actually move the second matrix up.
So that's this one.
Yeah, so the bigger one. And there needs to be, in order for matrix multiplication to work, there needs to be in the first matrix the same number of columns in that matrix as there are rows in the second matrix. But they create a matrix which is the rows of the first matrix and the columns of the second matrix. Now what's really cool about this trick is that second one moved up to do the matrix multiplication. Allows you to see this empty space, and you just need to fill in this empty space. And the way I think about it, I don't know if it's kind of helpful to people, is that I take the first row, A and B, multiply it by the A and the C, and then that got in the top one, and then drop that into the top left-hand corner. So I like to think of it as kind of like pouring a liquid, so A and B being the liquid, and pouring it through the A and C at the top, and it drops into that top left-hand corner. And again, you do that with the C and the D in the first matrix. Think of that as a liquid, and then drop that through the A and the C again. So you're multiplying C by A and D by C, and then that drops it into the bottom left of that matrix. And you do that again for all of them. Now we've got simple. You've created simpler matrices
just on
the
a quick
other ones.
simple example. If we switch across, like so.
And it's, so going through some actual numbers makes it kind of a
little bit easier,
doesn't it?
And what this process is, it's called the dot product. So, for example, if we just do this example of 1, 2, 3, 4 times by 1, 2, 3, 4, it's worth noting now before we even do an example, if the numbers were different, so say we were doing 1, 2, 3, 4 by 5, 6, 7, 8, multiplying 1, 2, 3, 4 by 5, 6, 7, 8 will give a different result to 5, 6, 7, 8 by 1, 2, 3, 4. because matrix multiplication is not called commutative. So commutativity in normal just numbers that we know and love, 1 times 2 is the same as 2 times 1, for example. But this is not the case for matrices.
You just can't do that with matrices.
Which is annoying.
Yeah.
But there is a reason behind that with when we look at the inverses, which we then use to solve simultaneous equations and things like that.
Which we'll learn more of in year 2.
So let's have a little look then, shall we? So as Natalie quite rightly said a couple of seconds ago, to get the top left one, the A, we pick up 1 and 2, we drop it through the first column, so 1 and 3. So we're going to do 1 times 1, which is the top left by the top left, and then we're going to do 2 times 3, which is top right by bottom left, because we've dropped it through. We add those results together and we get 7.
So A in this example is 7, that
yes.
top left-hand
and we can replace that now, look,
cool.
with that magic swipe.
Magic swipe. So the next one you're going to do, you're going to go across the way, so the next one you're going to do is B.
Yeah, B, why not?
Yeah.
I mean, you can do C next, you can do D.
Yeah.
I just put letters as placeholders because otherwise I get confused.
Yeah, no, that's,
so then this time we're still picking up 1 and 2, but we're instead of putting it into the left-hand column, we're going to put it into the right-hand column. So then we go and pick it up, we're going to drop it through, as Natalie said. So we're going to be doing 1 times 2 plus 2 times 4, which is 2 plus 8, which is 10.
Okay, and
so let's replace the B, and we've dropped it in.
Yeah, perfect.
Magic.
So now you're going to do the same thing with 3 and 4.
Yeah, so the bottom row, exactly the same way as we did the top row.
Yeah.
And this method can be applied for even bigger dimension matrices as long as the number of rows in the first is the same as the number of columns in the second.
It's the other way.
Other way around?
Yeah, columns in the first.
I
rows
do this
in
all
the
the time.
yeah. That's why this trick is really good, because you can see it visually.
Yeah, you can visually
rather
see.
than actually have
because
to think about
if
it.
I put, for example, another row on my left-hand matrix, it wouldn't work because the dimensions just don't work. So that's one of the key reasons that Mirko's trick is literally amazing. Thank you so much.
Thank you, Mirko.
So
we're doing C.
Let's do C.
Yeah.
So pick up 3 and 4, drop it through. 3 times 1 plus 4 times 3 gives us 15. So we've got one final one to do.
And
we're nearly there. So we pick up 3 and 4. We drop it through the right-hand column, so 2 and 4. We get 3 times 2 plus 4 times 4. 6 plus 16, which is
22.
22. And I don't know. That looks like it's done to me.
Yeah, it looks like it's done.
We can't put how much though, because it isn't a proof, unfortunately.
But it's not a proof.
We can hope.
But we can say it's done.
We can say it's done.
We're finished. Yeah. But yeah, so that's how you do a matrix multiplication. I hope that's been helpful. And we'll see you next time, whenever that is in the current environment. But before we go, wash your hands.
Yes, remember to wash your hands.
And to green bottles if you like. So anyway, thank you very much from Maths at Derby.